In this video, we're going to do the notes for 7.4. So 7.4, the heading is Binomial Random Variables. So the question is, what is a binomial random variable? So a binomial experiment consists of a series of repeated identical trials satisfying these conditions. Okay, so these are your conditions. So there must be a fixed number of trials, so a definite number of trials. We're going to call that trials n. Each trial must have two possible outcomes, called one success and one failure. The probability of success must be the same on every trial. So P is the probability of success, and the probability of failure is going to be Q. And notice that they will sum up to 1. The trials must be independent. In other words, the outcome of one trial cannot affect the probability of another trial. And the last one, the random variable x is the number of successes in the n trials. This is called the binomial random variable. So that's your x, okay? All right, so in terms of figuring out the formula, this is what we're going to use. The probability of x happening equals, so this is this. Remember we used this before? So this is for combinations, not permutations. So your n is your number of trials, and the x is the number of successes. So we're going to use our calculator to write this out. And then here's P is the probability of success, and that's x is the number of successes. Q is the probability of failure, and then n minus x is that. So let's try to use this given a problem. It'll make a lot more sense that way. So let's go to the next page. So I'm going to write that formula down again. So let's write it like right here. So try a problem. Okay, so let me do this. Let me say that the probability of x equals, okay, I prefer to use this notation, and then this is going to be P of x, and then Q of n minus x. Okay, so that's our equation. So here's our problem. Nikki is going to shoot 5 shots. 5 shots, that's her n. Okay, so 5 is the n. So let's start writing this out. So the probability of x, we're just going to write that for right now. N, 5 trials, and she is, and then x is the number of shots she hits in the 5 attempts. Okay, so far we have that. Then next thing, take your probability. She's a 60% free throw thrower. So that's going to be 0.6, and that's raised to the x, which is her success. And then 0.6 taken away from 1 gives me 0.4, and this will be n, which is 5, minus x. Okay, so that's the setup. So you want to go back and make sure you understand that. So how am I going to do this? If you want to know, if you're going to use this binomial probability density function, and you want to know the probability that Nikki hits 3, I have to make some adjustments. So this is your generic, or we'll say, generic formula. Okay, that will let you find any x that you want. If I want to have x be 3, I make these adjustments. 5 c to the 3, and then times 6 to the 3, and then times, and this is, 0.6, and times 0.4 to the 5 minus 3, so that's going to be squared. Okay, so this is one way we can do it. So we're going to use our calculator and plug in those numbers. So when you do that, I'll tell you what we're going to get. Okay, remember that to get this, you're going to use the math key. You're going to say math, and then probability, and then go down to find the right key. So when I do it on my calculator, I need to put the 5 in first, then go to math probability and grab the NCR, and then plug in, then hit it, and then end it with a 3. And then we're going to use just 0.6 raised to the 3 times 0.4 raised to the 2. And when you do that, you should be getting 0.3456. Okay? Now, there's a way to do this on your calculator, a different way. And that way on your calculator is going to be, if we go to, you're going to go to second, and then you're going to go to VARs. And when I hit that, so I go to second VARs, I'm getting distributions. I'm going to then go all the way down, and I'm going to go to Binomial Pdf. Okay, and when you go into Binomial Pdf, you're going to plug in the number of trials first. So this is the order. So you have to do your trials, which is your n, and then you have to do the probability. So your probability of success, and then you have to do your x. And they should each be connected by a paren. Okay, so when I put this in my calculator, what I'm going to plug in is, this is going to be 5 trials, this is going to be 0.6, and x is going to be 3. That will give you the same answer. If you plug that in your calculator, and again, this is by Gnome, I want PDF, and you will get the same exact answer, 3456. So this is the quickest way to do it. I want you to know this way as well, but know that this is the quickest way. Now, notice that when you use this formula, you can only do one x at a time. Okay, but you can use this formula that I just stored and put it in your equation editor. So go like this. Put for your y1, you're going to type in this from math, and then this raised to the x, and this. And then once you have that in there, I want you to go to second table set and start your table. So second table set, and then you're going to start your table at 0 and go up by 1. Then once you have it set, say second quit, and then go into second table, and you'll be able to read off each of these numbers. Okay, you'll be able to read each of these off. Then if you want to have probability of getting either a 0 or 1 or 2, you would then add these 3 up. Okay, there's also a way to do this with your calculator. So let me tell you how to do that. If you want to have a range of numbers, you're not going to use Binomial Pdf. If you want to do a range like this, you're going to do Binomial Cdf. And you would put the same numbers in. Let's see, I'm going to do it at 2. And that will sum up probability of 0 plus probability of 1 plus probability of 2. Okay, that will give you the sum. Okay, so you could either do it like this with your equation editor and manually sum them up, or if you have a range of numbers, you can do Binomial Cdf. If you have one number, you're going to do Binomial Pdf. And the way to keep this straight is P is precise. So only one value. Okay? All right, so let's go on to the next page. Oh, and I should tell you what I got for these. So I'll fill these in for you. Okay, 0, I got 0, 1. For 1, I got 0, 8. For 2, I got 0.23. For 3, I got 0.35. 4, I got 0.26. And 5, I got 0.08. Notice that they sum to 1, which is what I want. And as I said, you can get this by using your equation editor and then reading this from the table. Okay, let's go on to the next page. So here it says, what if we want to find the probability that Nikki makes at most 3 of her shots? Okay, so that's what we were just talked about. So we're going to do it explicitly here. So if she makes at most 3 of her shots, that means that she can make 3, 2, 1, or 0. So this is what we're going to try to do. So remember, there's 2 ways to do this. You can use your table, and in your equation editor, you're going to put the following. So y1 is going to equal 5 C3, and then 0.6 x and 0.4 to the 5 minus x. That goes in your equation editor. And then you go to your table and you get to read out P1, P0, which I'm going to write them down here, 0.01 again, 0.08 again, and this is 2, excuse me, probability of 2, and that's going to be 0.23, and probability of 3, which is 0.35. Okay, so you're going to sum those up, and your sum will be 0.67. Or you can use, if you go to second Vars to get the distribution, you're going to use binomial, because you have more than 1, you've got a range, you're going to use CDF, and you're going to say 5, 0.6, 3. This will get you everything to the left, so less than or equal to 3. That's what that's going to get you. Okay, so that's one approach. If you're doing the equation editor approach, you can also do an indirect approach, and that's using the complement rule. So because I have to add up 4 terms, I can instead just get 2 terms and subtract them from 1. Okay, so the probability of this Nikki shooting at most 3 of her shots is 1 minus the probability of the sum of P4 and P5. So this is going to be 0.26, and this was 0.08, and so you're going to get about 0.66, which is pretty close to 0.67. So you can get it either way. The complement rule approach is really, really good, because sometimes that will save us a lot of work. Okay, so just be aware of that complement rule. Okay, so then it says try this. Mindy is taking a 10-question true-false test. She forgot to study, so she is guessing at all the answers. What is the probability that Mindy will get all the answers correct? Okay, so that's one thing. So if she getting them all correct, then she has, let's see, she has a trials. She has 10 questions, so the trial's 10, and then the correct will also be 10. That's what that problem is going to be. Now, what's our probability? If she's guessing, your probability is going to be 50-50. Okay, so the probability equals 0.5. Okay, and then look, Q is also 0.5. What is the probability that Mindy will get at least one answer correct? So that means that she can get 2 answers correct, 3 answers correct, on and on and on. This is a situation where you would probably want to do 1 minus p of 0. Use the complement for this. Okay, so let's see what we want to do here. So we want to talk about the Binomial CDF and the Binomial PDF, as well as the other approach that we've been going through with this. And let me just see if I have room on the next page to do this. And no. Okay, so we're going to squeeze this here. Okay, so this is what we're going to do. Why don't I just rewrite some of this? I'm going to put this here and this here, and that's going to allow me to free up all of this, and then I will say that this equals 0.66. Okay, so that ends there. So now let's do our A up here. So what's the probability that Mindy will get all the answers correct? So the probability of X equals, okay, so this is 10, choose 10 correct, 0.5 up to 10 times 0.5 to the 0 power, and we're going to figure that out. So this is what goes in your calculator, and let's get an answer for that. So you should get 9.77 times 10 to the negative 4th. So not very probable. Okay, what else could I do? I can use Binomial PDF because I have a Binomial CDF because I have a range of values. Right, so let's talk about that in just a sec. Okay, so I think I may have misspoke. Because I want to know what's the probability that she hits all 10 answers correctly, that's going to be Binomial PDF. So we're going to use Binomial PDF, and what we're going to say is our numbers will be 10, that's number of successes. Actually, that's number of, let's see what I'm doing here. Okay, so it's going to be 10.5, comma 10. So that's how we're placing it in. And when you do that, you get the exact same thing. So remember, to get that, you're going to go to second Variance, go all the way down to Binomial PDF. And the first one is trials, so 10 is trials. 0.5 is the probability of success, and 10 is the number of successes. So 10 is your X. So that's the order that you enter this data in to get the same answer that we got by using the longer equation. Okay, what is the probability that Mindy will get at least one answer correct? So what you want to do is do 1 minus p of 0. And we're going to do the complement. So how do I get p of 0? And I'm going to say that's going to be 0, so let me just put a 0 there instead. So here's my 0, and that's going to equal how many trials? So it's 10, and choose to get 0 correct, times 0.5, 0, times 5, 10. Okay, times 0.5, 10. Okay, so what do we get there? So if we plug that in, I should be getting 0.9990. How else can I do this? Well, I can use Binomial PDF again, and I'm using the PDF because I'm testing if they're just going to get 1, if they're going to get 0 correct. So I'm going to say 1 minus, but now I'm going to put in Binomial CDF. I still have 10 trials. I still have 0.5 for the probability, but I'm going to put a 0 here. and I end up getting the exact same answer. So 1 minus that also gives me 0.9990. Okay, so either way you can get your answer, which is very, very good. Remember I did, I want to do, yeah, this is PDF, sorry, this is PDF. PDF and PDF, yes. Okay, so I'm doing PDF for both of those, and I'm just checking one little thing. Okay, let's go on to the next page. And let me go back. Okay, is this the next page? Yes. Okay, yes. All right, so sometimes they give you information about the mean, the variance, and the standard deviation, and sometimes they don't. So if you have to get an approximation of this, or if you have to calculate it for yourself, this is how you get your mean. The mean is the number of trials times the p. So in our situation, it would have been 10 times 0.5, and that's your mu. So 10 times 0.5 ends up giving you 5. Okay, your variance, okay, so this is your mean. This is your variance. How much do you vary around the mean? So to get that, you're going to take your 10 times your 0.5 and then times your 0.5 again. So 5 times 0.5 is going to give me 2.5. That's my variance. Okay, your standard deviation is just the square root of your variance. So take the square root of 2.5. And I am getting 1.5811. Okay, so we could calculate all of those. So I will always give you these formulas, but you need to know how to that you can use them to get these things, okay? All right, let's go on to the next page. Okay, so we're going to go to this Nikki problem. It says the Nikki problem was expanded, and we're asked to find the probability that Nikki hit at most 3 times in 5 attempts. Okay, so this is going to require a cumulative distribution function. Okay, so let's talk about doing this with our calculator. So what we're going to do is this. Go to second varies and look for Binomial Cdf. Okay, it looks like this. And this is going to compute whenever you have x less than or equal to some k. In our situation, k is 3. So here's your code to put in. Here's your binomial, and this is the number of trials. Here's your probability, and then this is telling me that she has to get x is going to be less than or equal to 3. Okay? When we do Binomial Cdf, we're going to do a range. When we did Binomial Pdf, we did one value. And what you should be finding is that you can get 0.6630. Okay, we also could have done this by the longer way. So the probability that x is greater than or equal to 3 is the same thing as saying the probability that you're getting 3, 4, or 5. Or you can do 1 minus the probability of getting 0, 1, or 2. Okay, or you can do 1 minus probability of getting x less than or equal to 2. So there's numerous ways to get this set up. So if x is going to be greater than or equal to 3, remember your x has to go the other way. You can't work on greater than or equals. You can only work on less than or equals. And that's why we're going to do it this way. So you've got to change your reasoning to this. Now, I'm going to show you, we're just going to do this again using the Binomial Cdf function. So you would say 1 minus, and then the Binomial Cdf. So Binomial Cdf, remember the Cdf is for a range. And you're going to type in 0.6, comma, and then 2. And when you do this, you should be getting 1 minus 0.6826, which equals 0.3174. So I just did that one way. So this Binomial CDF and Binomial PDF is a very, very nice key on the calculator. It will save you a lot of time. And it is all about binomial random variables. That's when we want to use it, when we have a binomial random variable. And this concludes this video.